All right, so I talked about true experimental designs. So now these are what are called quasi-experimental designs. And quasi-experimental designs, the biggest thing is that they don't use that random assignment. So they don't meet the requirements to be considered true experiments. And because random assignment is the most difficult of the requirements to meet, that's the one that they're not meeting. So they have two groups and they're measuring the dependent variable after the fact, but they can't meet that random assignment requirement. So then it becomes a quasi-experimental design. So there are three major types. You've got non-equivalent control group designs, before and after designs, and ex post facto control group designs. And I like this too. This is definitely a quasi-experimental design where they're saying, okay, let's slowly lower in the grant money and see how the little tiny academic mice, how they respond. All right, and that would be quasi-experiment. So the non-equivalent control group design. So in this one, you have a control group that is selected to be as comparable as possible to the treatment group. So it's not random, things are not randomly assigned, but you have your treatment group, and then you try to get a control group that looks as much like the treatment group as possible. And so there's two ways to do this. You can do individual matching, which is literally case by case. You find individuals to be in the control group that match similar individuals in the experimental group. And that would be things like you would match them on age and gender and race and whatever other variables. Maybe if we're looking at an offender sample, it would be the types of crimes they've committed, let's say, or how much time they've served in prison. So you would match on an individual basis. So for each person that you have in the treatment group, you have a comparable person in the control group. So that's definitely more time intensive and much more difficult to do, but it's trying to make it so that you don't have differences between your groups on a case-by-case basis. But then you could also do aggregate matching, which is much more common because it's easier to do. And this is where you basically use group level data to make sure that the groups are matched at that group level. So the groups have similar distributions on key variables, typically demographic variables. So again, things like age and gender and race and things like that. You want to make sure that they look similar on anything that you think is going to be relevant. So it's not an individual case by case, but it's aggregate matching. And then the before and after design. So these are where you don't have, there isn't a comparison group. So everybody is exposed to treatment. And it's called before and after because you measure them before and then you measure them after. And you see if there's a difference. So there's the comparison made between pre-test and post-test values. So this would be a case where a pre-test would be required. You wouldn't be able to do this with only a post-test. So while you typically would want a pre-test if you're going to do an experiment, whether it's a true experiment or quasi-experiment, you typically do want pre-test and post-test, but for before and after, there's nothing to compare if you don't do a pre-test. So you have to have a pre-test and a post-test, and then you compare those values. And so the simplest way that this looks is that you have a fixed sample panel design, which we know from our longitudinal discussion that that's the same people at two different periods in time, two different time periods. And so you have the same people, you've got one pre-test, and then you've got one post-test. And so you take those people and you measure them, and then you give them the treatment, and then you measure them after and see if there's a difference. And this is definitely more useful if you have multiple pre and post-test measures. So if you can measure them at a couple of different times, then implement the treatment and then a couple of more times. And so then you can see if there's no differences between their treatments before in their measures before the treatment, and there's no differences in their measures after the treatment, but there's a difference when that treatment happened, then suddenly there's a difference. Then that tells you more than if you just have two. But two would be kind of the simplest, is it's just one pre-test and one post-test. So, but where you could use this, if you wanted sort of more multiple pre and post tests, is if you were looking at something like a time series design. So you're looking at something over time and look at a variable as it changes over time. So something like if you looked at crime rate after the implementation of a certain policy or multiple policies, if you wanted to look at it. So let's look at crime rate, and then like here, and we draw a line in terms of where a certain policy was implemented, and then we see if that crime rate has gone up or down. And that's something that's being measured like annually, and we see if there's a significant difference at the point in times where certain policies were enacted. So that would be a before and after design. But a before and after design could also be you have a group of people, you measure them on some relevant variable, whatever you think the treatment is going to affect, you give them the treatment, and then you measure and see if it made an effect on those people. So they're both before and after designs. And so then the ex post facto control group designs, which is fun to say. This is where you have the treatment and the control groups are designated after the treatment has already happened. So this is why it's called ex post facto, because that literally just means after the fact. So you look at them, and in a way this is kind of more non-experimental than even quasi-experimental, because you're not even doing an experiment. You're just looking at them and going back and saying, well, who would have fallen into which group, and then see if there's a difference. But you would basically look at the groups and say, okay, so, let's look at a group of offenders who are out in the community now, and let's go back and see who had gotten this treatment when they were in prison and who hadn't, and let's see where they are now and who's different, and if the treatment group is actually doing better in the community. Well, it's ex post facto because you're not providing the treatment, you're not sort of implementing it in the middle of your design. It's already happened. And so you're just seeing if there's a difference now that they're out in the community afterwards. So that would be ex post facto because the groups were already decided, it's already happened, and you're just seeing if there's a difference. So it's not really an experiment, but it's still kind of quasi-experimental in the sense that you're still comparing two groups, and you have that post-treatment, post-test evaluation of the dependent variable. So, but the problem, of course, is that the control group is not going to really be comparable to the treatment group because everything's already happened, and you can't really know if the groups were similar or not beforehand because you're only seeing them afterwards. All right, so that's our different types of quasi-experimental designs, and so you can sort of think about how that relates to true experiments and where they might differ there.